These were the three problems that you were giving on your review, your pre-assessment, and one that no one in here should have had any problem with was the very first one, which was H of 2. If you had me last year, we spent 6 weeks doing this. So there's absolutely no reason that if you had me last year, you couldn't have done this. Even if it was a little fuzzy, you should have been able to do the first one. Even if you didn't have me, I know that Coach got over these, and you also saw them when you were in Algebra 1. So what this is telling you to do, we have three functions named here. This is function f of x. This is function g of x. This is function h of x. That's how they're pronounced. It is important because that's how they will be read. G of x. Now that doesn't mean anything. This x just means that's the variable that you're using. I can change that to a c and this one to a c, and that's the same thing. Now it's just function g of c, and c is the variable being used in the problem. So what you're going to do when you see h of 2 is you're going to pull function h, because that's the function they called for when you saw that h, and you're going to write down function h. Except now it replaced the x with a 2, so it expects you to do the same thing. Therefore, everywhere you see an x, you're going to plug in a 2. Please pay attention where I put that squared, outside the parentheses. It must stay there. Now, if there is a numerical value in that parentheses, you are allowed to use your calculator to get your solution. Again, you can, if there's any variables, you have to do it by hand. But if not, you can type it in exactly as you see it with parentheses and all. And your answer to this problem is 20. That means when the x value is 2, the y value, or your solution, is 20 for this problem. And those type of problems are seen quite frequently. It doesn't really matter, which type of problem you see. If I were to put f of 0, same thing. This just means I need function f. I know because it says so. It was an x. I changed it to a 0. So everywhere I see an x in the problem, which is right here, I'm going to replace it with the 0. So I could type that in again because I don't see any variables, so that means that is calculator friendly. 0. That means when my x value is 0, my y value is 0. Now that also means that if I were to put function h into the calculator and graph it, that the plotted point 220 is guaranteed to be on that graph because the x value is 2, the y value is 20 in function h. That means 220 is guaranteed to be on that graph. On f, that would mean the point 0, 0 is guaranteed to be on that graph because when I plug in x value of 0, and I know that because it says x, my solution is 0 or my y value. Now they do get a little more complicated than that, so let's talk about a few other examples. Here's an example that frequently confuses people when you see this right here. When you see a negative x, students just like to change everything to negative and think that that's what that means. It means that everywhere you see an x, you are now replacing it with a negative x. Now this one, for some reason, it confused the students last year, confused a few in class this year. That squared is distributed inside the parentheses. Negative x times negative x is a positive x squared because the negatives cancel and 1, 2 x's. So that becomes 2x squared. Now I done take care of the exponents. I need to work on my please, excuse, my dear. So it's multiplication and division. Multiplication would be this one when I distribute. That becomes positive 2x squared. Negative 3 times negative x becomes positive 3x squared. And that is your solution. Now, it doesn't seem like a very comfortable solution because the only thing that changes is the value in front of the 3, but it's still your answer. There's nothing more I can do that can't simplify, can't get any slower, can't combine like terms. Therefore, that is your final answer. Students sometimes see problems when they see things like this. Because they look at it and they think, well, G says 2c minus 9, and that says 2x minus 9. The problem answer must be 2x minus 9. That's not the case. What you're going to do is everywhere you see a c, you're going to write whatever is in that parentheses. Doesn't matter that there's a negative 9 at the end and 2 in the front. That's not what they asked. So here, do we have, please excuse my dear Aunt Sally, PEMDAS, parentheses. There's nothing I can do there because they're not like terms. There are no exponents. Then that would be multiplication. I'm going to multiply that 2 to everything inside of there. 2 times 2x is 4x. 2 times negative 9 is negative 18. And then I would just bring down that negative 9 because there's nothing to do there. So I'm looking for like terms. Right there, we would get 4x minus 27. That's your solution. Really big difference between 2x minus 9. So y'all need to make sure that whatever is in this parentheses is what you're substituting in everywhere you see whatever variable is listed in the problem. One problem that I saw many students have was this. They were able to say, okay, I see h, so I know I need to bring down function h. Some of them were even able to say, I know I need to substitute in there the problems that we have. But after that, students get a little sketchy with the exponents because there's nothing inside the parentheses that can be done of either one of them. So it's the exponents that get them. Now what that means is this 2 gets distributed to both terms inside of there. 3 is a term, x cubed is a term. So that means the 3 gets a squared, and the x cubed, which already has a 3 there, also gets a squared. They both get it. Now, if you do not remember this, I highly suggest you write this over to the side, underline it, bold, make some notes of it. The rule if you have an exponent being raised to an exponent, you multiply. If you have an exponent being times by an exponent, you add them. Now, we went over this last year in my class. I know it's been many a moon since we've seen it, but this is something you need to do a little design around. I'm going to look for it in your note check. It's very important. Knowing these rules over here, that means we're going to go ahead and distribute. 3 squared is 9. X times 3 times 2, which would be x to the 6th. We finished that step. Now what we're going to do is to distribute. That's the last term. So we have 4 times 9, which would be 36, x to the 6th. 6 times 3, which would be 18, x cubed, minus 8.